Welcome to the Bible and Science. This is Dave Prentice. I'm a retired public high school teacher, certified in all branches of science and math. I've also taught on the Bible and Science for many years, both in the U.S. and on many overseas mission trips. This is the Bible and Science, episode 17. We started talking about the Big Bang before, and we're going to continue on that today, and possibly even a little bit into the next time, and then hopefully get into the age of everything, the Earth, the universe, and so forth. So the question is, how persuasive is the case for a Big Bang? If you're going to try to deal with the origin of the universe, there are four major areas, at least, that I break it down into. Others might do it differently. But the first question is, how did matter and energy come into existence? Is there some natural explanation? No, we looked at that. There's no known natural explanation. It's something outside of nature. Could be supernatural, could just be unknown natural things, but we don't have an answer for that question. And then once matter and energy came into existence, do we have a naturalistic explanation for how they got from there to their present condition? That's what we've been working with. Was there perhaps a singularity that popped into existence that later would contain all of the matter and energy in the entire universe, and then it exploded in a big bang and developed into the known universe? That's what we've been on and continue to be. And later on we'll talk about, is there a naturalistic explanation for how life began? And then once life began, somehow, do we have a naturalistic explanation for how it would have gotten from there to its present state? Specifically, would it have evolved? So there are three possible explanations for the universe. One is it's all just natural processes. That's materialistic or atheistic evolution, which is what is presented to just about every student everywhere. Number two would be that there's some sort of a God who's using a process of evolution, theistic evolutionist, and then that there's some sort of a divine creation process, something like what the Bible describes. Students are almost never told that there are any valid arguments for number two and number three, theistic evolution or divine creation. They're just blanketed with the idea that it's all materialistic evolution. There are three main reasons that people believe in the Big Bang. Number one, those that are into this sort of thing would hear about the redshift of starlight, which is one of the technical arguments. Another one is the cosmic microwave background radiation, or the CMB, but most people have never studied those. Instead, most people believe in the Big Bang because that's what they've always been told happened. I want to alert you to a problem that's common to both creation and evolution, Big Bangs. This is commonly known as the horizon problem. Creationists must appeal to some unknown process to explain how could the light from distant stars have reached Earth in only a few thousand years, and we'll get back to that question later on. But it's very likely that this process is something that will never be explainable by purely natural laws. Okay, so creationists are in trouble, evolutionists are off the hook, right? Nope, not at all. Evolutionists believe that the age of the universe, the time since the Big Bang, is about 13.8 billion years. So we point our telescopes toward the farthest reaches of the universe, supposedly 13.8 billion light years in each direction. And what do we find? The energy level is almost exactly the same on all of the edges. We measure it using our technology, radio telescopes, infrared, and all things like that. And we find the energy level is almost exactly the same. But why should it be? If there was a Big Bang and it's expanding outward in one direction and another direction, it's not reasonable to expect it's going to be perfectly uniform in all directions. So we've got One part that's 13.8 billion light years away in one direction, another one 13.8 billion light years in another direction. Every direction we look, it's the same energy level. Why? It should have taken at least double that amount of time, 27.6 billion years, for energy traveling at the speed of light to reach from one side of the universe to the other in order to even out. But even if it's been 13.8 billion years, that's not enough time. So evolutionists, like creationists, have not been able to find any natural process to explain the evenness. It seems also to have been some non-natural process. And remember, the whole point of evolution is to explain everything by purely natural processes and laws, and they can't any more than we creationists can. When you analyze the radiation out in space, it was first discovered back in the 1950s by Penzias and Wilson of Bell Labs, who got a Nobel Prize. They were pointing their radio telescope out through space just to see it, just to calibrate it. They focused it on what they thought was an empty area of space. The problem was it wasn't empty. There was a little bit of a hiss. So they reoriented the telescope, pointed it at a different region, same results. Everywhere they pointed it, they got the same results. And they finally concluded there's a background radiation field out in space. Well, since then, this has been used as one of the arguments for the Big Bang, but it's not. The wavelength distribution of the cosmic microwave background shows that the energy level is 2.726 kelvins, 2.76 degrees above absolute zero. This is based on data from the Cosmic Background Explorer satellite. When I was studying physics, I learned that a wavelength distribution, like what you see up at the top of the page, usually indicates black body radiation, which is caused by objects in space or objects anywhere emitting energy at the same rate they absorb it. That's exactly what we see out in space. So what's absorbing and emitting background radiation? We're not completely sure, but it would be consistent with the idea of something as simple as dust throughout space emitting energy at the same rate that it absorbs it. So back in 1992, NASA released this image, and it was on all of the news media, and it was headlined as the biggest story of all times. The cosmic microwave background radiation, it turns out, is almost perfectly even in every direction. The image that you see there is kind of deceptive because there was computer manipulation. You couldn't look through a telescope and see this, but the information that came in was interpreted by computer programming, and it gave hot spots, cold spots, hot spots, cold spots. Turns out, nah, they messed up on their interpretation. The programming was wrong. The actual energy level of the microwave background radiation is almost perfectly uniform, down to 30 parts per million. Why should that be? The universe is lumpy. We've got stars and galaxy clusters. Why should we have a perfectly smooth background radiation? I think perhaps we don't completely understand the background radiation. Here's a little problem that's a big problem. There are objects in space called quasars, quasi-stellar objects. They're extremely bright, but they pulsate rapidly between bright and dim and bright and dim and bright and dim. So the rapidity of the pulsation would indicate they're relatively small. They have very high redshifts. So since we're interpreting redshifts to mean the distance and the velocity, they're believed to be among the most distant objects in the universe. Well, here's a problem with that. Under laboratory conditions, scientists have derived something called the Stefan-Boltzmann law. It says the energy output of an object radiating energy is proportional to its surface temperature and the fourth power of the temperature. This is determined by laboratory observation. There's no known way an object as small as a quasar could get hot enough to be so bright if it really is billions of light years away. We don't understand. So either we're wrong about the Stefan-Boltzmann law, which was derived from observation, or else we're not completely sure about what all the redshifts mean. Some of them, maybe we're confident. Others, maybe we shouldn't be quite so confident. The quasars, they have a real problem for us with their redshifts. Why would things be redshifted? The light traveling from a source at A to a receiver at B would receive, in classical physics or Euclidean geometry, would receive a redshift simply because it's moving away, the Doppler effect. So the waves are stretched out. We use that shift to determine the distance and the relative speed between point A and point B. But according to all of the Big Bang models, space is not completely flat. There's no such thing as a straight line when you're looking on large enough scale. This depends upon non-Euclidean geometry. Relativity says that light traveling from point A to point B is not going through space, it is space. A to B is the expanding cloud of the Big Bang. So as it stretches out, space is stretching out. The redshift actually can only tell us the factor by which the universe expanded while the light was in transit. You can't use it to determine the speed of expansion or the age of the universe. It's just, this is how much the universe expanded while the light was moving from point A to point B. So if the universe is the result of a Big Bang, then the stars and galaxies near us should have relatively very low redshifts from our perspective, sorry, and those far away should have high redshifts. For objects in between, there should be a continuous distribution of redshifts. There's not. Redshifts occur in discrete intervals, which have been calculated to represent a distance from one group to another group to another group. Each difference, about 72 kilometers per second. Why should there be this quantization of redshifts, these distinct numbers? If you're driving down the highway and you're looking at other cars, you're expecting, well, some are going to be at 50 miles an hour, 52, 54, 56, 58, 60, 70, and so forth. But you would be amazed if you pointed your radar gun and found out that, oh, there's a whole group that are at 50. Nobody's at 51, 2, 3, 4, 5. And then here's a whole group that's at 60. Nobody's at 61, 2, 3, 4, 5. And there's a whole group at 70. Nobody's at 71, 2, 3, 4, 5. There's no explanation for that on the highway, and there's also no explanation for that in physics. The quantized redshifts, oh, here you go. This is one that those crazy creationists are making up. Some would point out that the quantization of redshifts would make sense if the Earth was near the center of a three-dimensional universe, a non-Big Bang universe, a three-dimensional universe. The Earth being near the center? Wow, didn't we disprove it? No. According to relativity, there's no such thing as a preferred frame of reference. I think perhaps there is. If the universe expanded uniformly through three-dimensional space, then an observer not near the center would see a continuous range of redshifts. Those would be determined by the distance of each galaxy that was emitting light. So about 2 million light years from the center, if you look at the graph at the upper left, you'll see the distribution of redshift. It would probably look something like that. But look at the upper right. If there was an observer near the center, that observer would see redshifts in discrete intervals. the distribution would look something like that. That's what we see. It looks very much like the Earth could be near the center of the universe. What? The universe has a center? Not according to Big Bang cosmology, but according to common sense. Okay, if God started at the center, the Earth was near the center at the beginning, or at the center, and of course it would have moved since then, but as time has gone on, the Earth is not that far from the center of the universe. So what if evolutionists find something that can't be explained by known natural causes? No problem. Must be unknown natural causes. We certainly can't allow anything from God, no divine causes. So evolutionists are going to make up stories about unknown natural causes. One of them would be relating to why things can cluster together. If there was a Big Bang, things should be expanding outward forever, but somehow they don't. They're lumpy. We've got stars and galaxies and galactic clusters and things like that. So there's a new story, relatively new story made up called cold dark matter or dark matter. It would act sort of like an invisible glue holding together large cosmic structures for billions of years. The reason it was proposed is because there's nowhere near the amount of matter needed to pull together galaxies, galactic clusters, and so forth, but yet there they are, and we can't allow God to have created them, so let's invent something called cold dark matter. In order to salvage the multi-billion year time frame needed by Big Bang cosmology, evolutionists have to believe that 90 to 90% to 99% of the matter in the universe is invisible. And as alternatives, some have proposed string and texture theories, which depend on the existence of something called a Higgs field. Now, a little while ago, when I was talking about my fried egg story about the origin of fried eggs, where a supernova released a burst of energy that hit a satellite, bounced off, hit a chicken, which exploded, and the egg cracked and fell away. So the egg was sailing through the air, and as it was approaching a window, the window was closed. So suddenly a hypothetical force field, which I called an eggs field, would appear, open the window. When the egg came through, the eggs field would come back and close it. The reason I use the term eggs field is because evolutionists believe that there are these mysterious entities called Higgs fields. They appear and disappear as necessary to make the mechanics and mathematics of a Big Bang work. But if the universe is not many billions of years old, then cold dark matter is not needed. The reason we call it cold dark matter is we can't detect any energy, so there's cold. We can't see it, so there's dark. But maybe it's not there. Then there's also something out there that's been proposed called dark energy, which is an attempt to explain why the universe seems to be speeding up in its expansion. And this is something that was put out there because there are at least dozens of supernovas that are dimmer than they were expected to be according to present Big Bang models. So rather than say, the model may be wrong, we say the supernova must be dim because the universe is expanding at an increasing rate. That would mean that over 80% of what comprises the universe is made of undetectable dark energy. Why is it called dark? Because we can't see it. It's undetectable. So we could say, well, maybe something's wrong, but no, that might point toward the possibility of God. So rather than discard the theory because it doesn't agree with the data, let's discard the data because it doesn't agree with the theory. But if the universe is not multiple billions of years old, dark energy is not needed either. So we've got a really smooth background radiation, and we've got a really lumpy distribution of matter. So how are we going to reconcile those two? There's been a proposal, quite a few people proposed that there was an inflationary period. So at the time of the Big Bang, at zero time, then between 10 to the negative 43rd power seconds, which is an itty bitty 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 bitty, and 10 to the negative 34th seconds after the Big Bang. During that time, space expanded at 10 to the 20th power times the speed of light, and lumps formed. And then it slowed back down to where it wasn't expanding faster than the speed of light anymore. Okay, why was this proposed? Because the universe is lumpy and we can't have any sort of divine creator. This idea, the model, violates the law of conservation of momentum, and it also violates Newton's second law of motion. There would need to be some sort of forces for the expansion to speed up and then to slow down again. What kind of forces are you talking about? Oh no, it's just made up forces that happen to appear and disappear, and this is only because you want the Big Bang to be true. And also, the inflationary models are still insufficient to account for the amount of clustering observed. It would take 60 billion years to reach the present level. And of course, I'm sure somebody's going to come up with another model to explain why it didn't take that. But all of this is to say it's got to be natural processes only. So I've mentioned the Big Bang Theory, but not so much, but a lot of other people talk about the Big Bang Theory. Great TV program, the Big Bang Theory. Well, the problem is there's not the Big Bang Theory. It doesn't even qualify as a theory because you can't test it. You can run mathematical models, simulations, so it doesn't come across quite as well on TV to have a program called the Big Bang model. Well, which model anyway? There's hot Big Bang, cold Big Bang, inflation, string, texture, little Big Bang, cold dark matter, dark energy, and many other ones. They're all models, which doesn't automatically mean they're wrong, but they do each contradict all of the other ones. So let's come back away from theoretical things toward practical things that have been derived by observation. Okay, the Big Bang says that there was this explosion and somehow it didn't keep going. It clustered together. Well, the law of conservation of momentum, which is one of the most obvious laws of science, of physics, would say if we have an explosion and something is spreading outward, it's going to keep going. There would have been nothing outside of the Big Bang for the expanding parts to hit. So they should have produced an eternally expanding cloud. Gravity would not have been strong enough to cause clustering. And then the second law of thermodynamics would say that a Big Bang would have started from a tremendous concentration of matter and energy, and it exploded in the most disorderly event of all times. The energy would immediately have begun to spread throughout space. Okay, that's consistent with the second law of thermodynamics. But then the problem is later, no, the energy kind of reversed its course and began to cluster again. It became concentrated in bodies that were going to evolve into stars, into galaxies, into galactic clusters, and so forth. That would be a tremendous decrease in entropy throughout that part of the universe. The second law of thermodynamics, which we derived based on observation, would tell us, no, that wouldn't happen. But if you're trying to get rid of God as the creator, you have to believe in something like that. Some have also proposed the idea of little Big Bangs. Instead of one all-inclusive Big Bang, if there were several little Big Bangs that interacted with each other, Well, that might possibly be able to overcome the problems of conservation of linear momentum and angular momentum. However, each of these singularities turning into a little Big Bang would be the result of a quantum fluctuation from nothing. The results of such fluctuations should be random and they should be unpredictable, yet we see the same types of matter and energy everywhere we look throughout the universe. And then the Big Bang says there was nothing outside the explosion, not even space. Space is four-dimensional according to the Big Bang. However, little Big Bangs would have occurred at many different locations. Location, location, location. That would mean that space already existed before they exploded. Space would have to be three-dimensional. And then, of course, the first law of thermodynamics says matter and energy don't come into existence or go out of existence by any known natural process. Well, you would have to postulate unknown natural processes because each time one of the smaller singularities appears, that was an unknown process. And here's something you might not have thought about. There's a lot of rotating objects throughout the universe. Any rotating object possesses a property known as angular momentum, which depends on the diameter and the speed of the rotation. So as the diameter decreases, the speed increases, and as the diameter increases, the speed decreases. So let's work backwards through time. Let's take an astonishingly small galaxy. They're much bigger than this, but let's say there's a galaxy that's only 1 billion miles in diameter, rotating at 1 mile per hour. Okay, move back in time toward the Big Bang. The galaxy had to be smaller and smaller and smaller, which must mean it had to be moving faster and faster and faster. At some point after the Big Bang, it would have had to be rotating far faster than the speed of light. Now, our practical physics that we've derived over the last few hundred years says that's not possible. So you can discard the things that we have measured and observed because you want to have something that hasn't been observed, that is the Big Bang. And the purpose is to explain everything by natural processes. We've got to get rid of God. A little trivial thing. Stars are supposed to have evolved over billions of years, which is much too long for human history to record. Well, in the few cases of rapid change we have observed, the changes have been toward deterioration, not increasing organization. We're told that there are about at least 100 billion galaxies of 100 billion stars each, and the Big Bang occurred 15 billion years ago. Well, that would mean that there would have to be an average of over 21,000 stars forming per second since the beginning of the universe. Why don't we see them going blink, 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 blink? Constantly new stars coming into existence. Every now and then somebody would claim they've seen a new one, but not 21,000 per second. And all stars are supposed to be performing nuclear fusion. Since the rate of fusion depends on the mass, the most massive stars should burn out first in a nova or a supernova. Then these are supposedly flung out into space, and young stars are formed by them coming back together, recycled supernova remnants. They should contain the heavier elements that are supposedly produced in the supernovas, while smaller stars should be able to go for billions of years without going through the nova or supernova state. The farthest visible stars we can see with our telescopes are supposed to be billions of years old, dating to shortly after the Big Bang. And the smallest of those extremely distant stars should not have gone through supernovas. There should be billions of stars containing only hydrogen and helium. However, using our telescopes, analyzing the spectra of what's in the stars, how many metal-free stars we discovered? 0. In fact, within 1% or so, stars that are supposed to be all different ages contain the same elements. maybe they're really not different ages after all. Some other things coming in closer and closer toward the Earth. NASA space flights tell us that each planet is made of a mixture of elements that are different from all the rest and from the sun. Well, how would this happen? If they're all the result of the same explosion, shouldn't they be made of the same stuff? And then a rotating object or an object moving in a circular path is going to have angular momentum due to its rotation. While the sun possesses 99% of the mass in the solar system, but it only has 2% of the angular momentum. The planets only have 1% of the mass, but they have 98% of the angular momentum. That's incompatible. Most people just ignore that, but it's incompatible with the idea of a Big Bang origin of the solar system. And each of the planets orbits the sun in a different plane. They're not all in exactly the same plane. Pluto, Mercury, and our supposed twin Venus, they're the most inclined with respect to Earth's orbit. And then get this, Venus rotates backwards from the rest, and Uranus rotates almost perpendicular to its orbit. That's going to be some fancy stuff going on in the Big Bang to make these things turn all different directions and rotate all different directions. And there are at least 11 moons that orbit opposite the rotation of their mother planet. And the moons of Uranus orbit almost perpendicular to the rest of the solar system. Now, here's your chance to put together a solar system. Could the planets have been captured by the sun's gravity? Suppose you have a turntable. If you're old like me, you know what a turntable is, a record turntable, record player turntable. Suppose you have a turntable with a magnet at the center, 9 individually adjustable rotating rings. Could you roll a steel ball onto the turntable and get it to orbit by exactly balancing the magnetic force with the outward momentum? Well, okay, let's push one in there, get one in orbit. Now let's do it 8 more times, one for each of the planets. And meanwhile, you can't disturb the previous balls that are orbiting. Okay, got 9 in place. Now do it at least 6 more times for each of the moons. Oh yeah, your problem is you have to do it in 3 dimensions, not 2 dimensions. Okay, you believe that this could happen? Even with all of our technology, there's no way we could put together an arrangement as complex as a solar system, but it's supposed to be the product of random chance. Remember, if you can't find a natural process, you make up a natural process. I've told you about the supernova and the elements. They're supposed to have been every single star in the whole universe going through a supernova. No, they haven't done that. But the process was repeat over and over, spreading heavy elements to every single star. It's because we're trying to explain why don't we see any metal-free stars? A Big Bang should give us a lot of them. We don't see them. So remember Occam's razor, entities should not multiply beyond necessity. The simplest explanation that fits all the facts is usually the best. I believe that there's a God, a supernatural God, who's responsible for the universe, and that's a pretty simple explanation. I can't prove it. I can't prove the existence of God, but other people are going to say, no, I'm going to give you a really complicated observation, haven't figured out all of the details, but I'll come up with something. Well, remember my story about the origin of fried eggs. Did a supernova release a burst of energy? It bounced off a satellite, hit a chicken, made it explode, sent a superheated egg sailing onto the plate, and along the way there had to be force fields opening and closing the windows. That's pretty complicated. I would tend to believe in that case that there was probably a cook. So I would tend to believe, in case of the universe, that there was probably a cook, God. Okay, so this has been pretty technical, pretty complicated, and we will get a little bit into how old is everything. It's a lot harder to determine how old is the rest of the universe outside of the Earth, but on the Earth, it's not that hard to analyze, so that will be our topic for the next time.